Hi team, Mr. Rator here. We're just going to look at this question 3 from June 2011 OCR paper S1. Okay, so first one is pretty straightforward. All you need to do, you can either just put this straight into your calculator and just work this out by saying this is to get probability of x is greater than 10 will be 1 minus probability that x is less than or equal to 10. Now, you can use your binomial function on your calculator. Just plug these numbers in where you got x is going to be the 10, and you've got to use the cumulative frequency one, so CD, cumulative distribution. Once you put it into that form, binomial CD form, cumulative distribution, x is 10, n is 12, and the probability of success is 0.85. So if you did that, you'll get, and then once you get the answer, which will, in this case, when it's less than or equal to 10, will be 0.557 to three single figures. Once subtract that, and you'll get 0.443. Okay, same thing, but this time you go on a PD, okay, particular distribution. So in this one, probability distribution of this, in this particular one, in this case, it's just probability that x is equal to, so don't forget this is less than or equal to, probability x is equal to 10, and if you just put that straight into your calculator, you'll get 0.292. Now, variance, the formula for binomial to get variance is n, p, and q. Q, in this case, is going to be 1 minus p. Okay, I'll just write it like that. So NPQ is Q is just 1 minus probability. So in this case, N is 12. Probability of success is 0.85. And probability of failure, which is 1 minus P, 1 minus the success, which is 0.12. If you multiply those three together, you'll get 1.53. And that is the variance. Now, going on to the second part, it goes a random variable y has the distribution binomial to 1/4 success. Two independent values of y are found. Find the probability that the sum of these values is 1. Okay, so first of all, let's write down the distribution of y. So first of all, we can have, so maximum successes is 2, so y can have 0 successes, 1 success, and 2 successes. Okay. Now, we're trying to probability distribution table here. The probability of success. Right. So here we've got no success. We've got 2 failures. So we've got a failure followed by a failure. So that will be, we're going to have 2 goals, no successes. So the chances of success is 0. So 1/4. Success is 0. And the probability failure is 3/4. You're going to get 2 failures. That will be to the power 2. Okay. This one, we've got probability of getting 1 success. So you can have 2 trials, 1 success. So we've got a 1/4 chance of a success. The other option is going to be 3/4 of failure. We've got 2 options there. And getting 2 success, so 2 out of 2, to choose 2, you'll get 2 successes. So the chance of success is 1/4, so you get 2 of those, and 3/4 failure is 0. Okay, so if you went and put those calculations in, or you put that through your calculator and put in 0, 1, 2, you'll get a table, probability distribution table, probability y equals small y. So the chances of no successes will turn out to be, well, we can just work this out here quickly. If I put 1, 2, then 2 here. So if I just quickly work this out, which you should be able to do, 2 choose 0 is just 1, times, not anything to the power of 0 is just 1, and 3/4 squared is going to be 3 squared is 9 over 4 squared is 16. Okay, so that's going to be 9 over 16. So this one's going to be 2. Now 1 times 3 is 3 over 4 times 4 is 16, and let's put 2 whole ones, 2 over 1, 2 times 3 is 6, and 1 times 16 is 16. And same with here, 2 choose 2 is just going to be, it's going to be 1 times, well, anything to the power of 0 is just 1, so that's going to be that squared. 1 times 1 is 1, 4 times 4 is 16, 1 over 1, that's just 1/16, so that's just basically 1 out of 16. And you should know that 9 plus 6 plus 1 is 16 over 16, so the table adds up to 1. The probability, sum of probabilities is 1. So this is the probability of getting 0 successes, 1 success, or 2 successes from this table. Now, it does say 2 independent, so we can just multiply them when we get them. Are found, 2 independent values are found. Find the value that the probability of sum of 2 values, probability that the sum of these 2 values equal 1. So what this is implying, so you could get the first try, you could get y equals 1, but in the second one, you must get probability y equals 0, because the sum of these attempts, the sum of successes must add up to 1. Or means we must add up. You could get in your first go, you could get y to equal 0 times probability on your second go, y would equal 1. Again, 0 and 1 would add up to 1, and that's where it is to find the sum of these values must add up to 1. Okay, so if we set this up, we know that here probability of getting 1 is going to be 6 over 16 multiplied by probability of getting no successes is going to be 9 out of 16. And this is going to be the same, but the other way around. That's going to be 9 out of 16. Probability of getting no successes times probability of getting 1 success is 6 out of 16. So what we get here, we get 27 over 128. And the same thing here, 27 over 128. So when we're working at the probability of getting a sum of 1, it's going to equal to these two probabilities added together. So we're going to get so y first go plus second go equals to 1. It's just going to be 2 times 27 over 128. I'm just going to cancel these down, which will give me 64. 27 over 64. Okay, so we can just leave that like that. Okay, let's go at the next question. Question 4. It goes here. Question 4, part 1, histogram. Here's the histogram, illustrates data, and it goes here. The height of the block when time is between 31 and 35 is 5.6. Find the height of the block for this interval. Okay, let's just quickly do this here. So we got here, so t, let's put the interval here. This is going to be second to 35.5. This is 30.5, because that will get rounded up to 31. This will get rounded down to 30. So that's just less than. Okay, and that's going to be equal to. So that gets rounded down. Okay, so the difference there is going to be 5. So the class width there, in this case, this class width, 35.5, took away 30.5, it's going to be 5. And the frequency is 28. So the frequency density is 28 frequency divided by 5, which equals 5.6, which is, in this case, the height. So when we're doing this, we're going to see the upper bound of this, which is going to be 30.5, take away 27.5, so that's, we're looking for the class width here. So 30.5 take away 27.5 is going to give me 3. Okay, now this one, the frequency is 4. So therefore the frequency density, which is going to be the same as the height, is going to be 4 shared by 3, which is also the same as 1.3 recurring centimeters. Okay, that's pretty standard, straightforward. Just need to be careful with these class intervals, so remember getting the upper bound and the lower bound correct. Right, the next one. The data in the table are used to estimate the median, okay, which is the middle value once they're all in order. State with reason whether the estimated median is going to be 33, less than 30, but equals 33. Now, first of all, let's think of what is the total here? 50. So I need to find where is the halfway value. So I'm going to do 50 shared by 2. That's going to give me the 25th value. I'm going to see where the 25th value lies. Now, looking at here, I know looking at 25th, I've got 4 values lying here. So I need to add 21 on this. I want the 21st value, where the 21st value lies here, because 21 plus 24 is 25. So we need to know where that 21st value lies at this 28. So what we can do, next process, we can do 21 divided by 28 and multiply by the class width. So the class width here, what we said here is 5. Times that by 5. Okay. If you do that on your calculator, you'll end up with 3.75. So this is how much, 3.75, how much I want to go in from this value, from the bottom. So we know that 4 are between 28 and 30. So starting from 30.5, I need to add on 3.75, leading from that lower bound, seeing how much value the median is going to be. So therefore, the median is going to be 30.5 add 3.75, which is going to give me 34.25, which means it's going to be more than 33, which implies the median is going to be more than 33. Okay, Now, sorry, I'm squeezing it all in, just wanted to get it all fitted here. So let's have a look at this next part. Now the next part, again, you can use your table and your calculator, put all these values in, or I'm going to just quickly do the table here so you can see what I'm doing. Now as I'm doing the table, I want to take up less space as possible. I'm just going to straight away shout out the midpoints on here. So time is going to be my first point. I'm using the midpoint here. So the midpoint, I'm going to use that here. Yep. Let's just draw the line coming down here. Just be careful. And for this one, I'm going to use the frequency. So I'm going to put F here. This is going to be my X. Over here, I'm going to then multiply that F by X, so I'm going to get the F and X. And along here, I'm going to then square this and get the Fx squared. Okay. So let's have a go at this. First of all, the midpoints here. Now I'm just going to use 27 for this. It won't make a difference because I'm going to multiply by a frequency of 0. The next one, I'm going to use halfway between 28 and 30 is 29. The frequency there is 4. The next one, I'm going to use the midpoint between 31 and 35 is 33. The frequency there is 28. Next one, I'm going to, right, the best way to find the frequency is add those two numbers, then half it. So that's going to give me 40.5. And the frequency obviously there is 14. I'm going to use the next one, it's going to be 53, the midpoint. And that's going to be, have a frequency of 4. And this one's not really going to matter, I'm just going to use 61. That's going to have a frequency of 0. So the top and the bottom don't matter so much. So I'm going to multiply those two. I'm going to end up with 0. End up 0 here. Also, whatever x squared times by 0 frequency, that's going to give me 0, and that's going to give me 0. So we can take away. So we get rid of those. Now, if we're multiplying these together, 4 times 29, you're going to get 116. Likewise, if you do 29 squared times 4, you're going to get 3364. Likewise here, if I do 33 times 28, I'm going to get 924. And if I do 33 squared multiplied by 28, I'm going to get 30492. Now if I do 40.5 times 14, I'm going to get 567. And if I do 40 squared times 14, I'm going to get 2296.3.5. And the last one, if I do 53 times 4, I'm going to get 212. And if I do 53 squared times 4, I'll get 11,236. Now, if I sum these values up, so I'm going to put here the line. I'm going to put the sums. The sum of frequency, obviously we know that's given in the question is 50. Okay. The sum of f of x is 1819, and the sum of fx squared is going to equal 680 55.5. Like I said, you can do this straight from your calculator. Just go to this out of the way. Okay. Now, if I just draw a line along here, just get everything onto one page. Now, if I want to get the x bar, which is the mean, that is the sum of f of x divided by sum of frequency. And in this case, sum of f of x is there, 1819 divided by sum of frequency is 50. If you share that by that, you'll get the mean to be 36.38. Okay, now the standard deviation. Before we do standard deviation, let's get the variance, get the formula, because then once we got the variance, we just need to square root that. So the variance is going to be sum of f of x squared divided by sum of frequency divided by what we worked out earlier on, the x bar squared. So now we know that we've just worked out what this is, so that's going to be 68055.5 shared by sum of frequency is 50. Subtract, the mean is here, 36.38 all squared. Okay. When you multiply that, just put it straight into your calculator, you'll end up getting 37.6056. So if I want, this is in question standard deviation, this is the notation for standard deviation. This is just variance square rooted, so 37.6056. If I square root that, that will give me, and to two decimal place, 6.13. So line, circle those answers. So there's your mean, and there's your standard deviation. Over here, there's the explanation for why median is more than 33, and this is the height for the frequency density. Okay, hope that helps, everybody.